Okay, let's give you guys some more practice. So here, using this theorem here, work out the limit of this. And what this theorem is saying is that when you're trying to find out the limit of something to the power of another thing. So for example, let's say you've got something in here. Um, let's say 3x minus, I don't know, 5 here, and you're trying to find out the limit of 3x minus 5 to the power of, let's say, 7. Well, what this theorem is saying is that you can just break you can just concentrate on finding out the limit of this thing here, and then whatever the answer is here, then you can just power that limit to the power of 7. So just like the square root, say, so you're trying to find out the limit of what's inside this bubble here. You, with the square root, you can actually just break into the square root. So you can just concentrate on finding out the limit of the bubble, and then whatever the answer is, then you can just square root the whole thing. This is similar to that, in that in that concentrate on finding out the limit. Well, this is similar in that it's saying that concentrate on finding out the limit of the bubble, and then whatever the answer is, then power that. So that's what it's saying. Okay, well, if you try and look at this graph here, if you try and look at this graph here, hang on. If you try and look at this graph here, um, I'm asking for the limit as x approaches 1. So 1 is here, and as you approach 1, this is slightly higher than as you approach 1. What is this limit here? And as it turns out that right dead on 1, nothing breaks down. Nothing breaks down. So this bit here is continuous. Um, it doesn't break down. That's just a clue. So you can, so that if it doesn't break down, then you know there's nothing cunning that you need to do. If it breaks down, then you have to find a cunning way of resolving that, like factorizing, or well, there are lots of tricks to resolve it. But here, nothing breaks down. It's continuous all the way through. But anyway, find out the limit of this. Okay, so hang on, let me put a theorem up. So here, find out the limit of this, and you can pretty much ignore this theorem, because what it's saying is that when you're trying to find out the limit of something to the power of well, you can just, what it's saying is that just concentrate on finding out this limit here. That's this thing here, and then whatever the answer is, then you can just power it, and that will give you that will give you this, which is the same as you finding out. Well, anyway, do whatever you find out the limit of this. Okay, so press pause and have a go. Okay, so to do this here, hang on, let me get rid of this. Okay, to do this here, visualize this bit as one block. So you've got one block multiplying another block here. Okay, and then from looking at this block here, from our knowledge of indices, if you have x to the power of a b here, so whenever you have a power of a weird fraction, which is in this case here, what you do is you break it up into x to the power of a, and then to the power of 1 over b, because when you get this times this, it gives you a over b anyway. So what I'm trying to say is that when looking at this here, view it as this. So you've got a bubble here, which is x plus 3 here to the power of 3 over 2. But rather than looking at this here, try to visualize as this: x to the power of, well, this thing here to the power of 3, and then that to the power of a half. Okay, to the power of a half is the same as square root. Okay, so well, anyway, so this block here then becomes this. So you've got this block here, and then this block here is this block here. Okay, and to the power of a third, that's like taking the cube root. Okay, and again, if you don't understand this bit, you have to watch the section on indices. So here you've got this here, So what we're doing is that we are trying to work this out here. That's this bit here, okay. And then whatever this thing is, then we can just square root it, because to the power of a half is the same as square rooting it. So yeah, so here with square root you can actually break into the square root. There's a theorem that says you can break into the square root. So looking at this here, that's just like me saying this: square root of x plus 3 to the power of 3. And then if you're trying to find out the limit of this here, you can just break into the square root, because there's a theorem that says you're allowed to do that. So now just concentrate on finding out this bit here. Okay, and then whatever this limit is, then you can just square root it. Same goes with over here. Over here you've got this here, so visualize it as the cube root of 2x plus 2. Okay, visualize it as this, and there's a theorem that says when you're trying to find out the limit of this here, you can actually break into the cube root and concentrate on finding this out, and whatever the limit of this bubble is, you can just cube root it. Okay, so from here from here it will take you to here. Okay, so hang on, let me scroll down, and then here you well, basically now you can just plug this into here. Nothing breaks down really. So here is you. This bit here will be 4 to the power. So this bit here, hang on, this bit here is 4, because well, as x approaches 1, this bit here will be 4. So 4, that will give you this here, and then to the power of 3, to the power of 3, and then later on you have to square root it. And then on this side here, this bit here will be 4, and so the limit of this bubble is 4. And then, well, if the limit is 4, you can just cube root the limit. That will, well, you're allowed to do that. So this then becomes this, okay, and then this thing here turns out to be a nice neat number 8. This thing here turns out to be an ugly number, this number here. So who cares? Just get this, multiply with this, and that will give you the limit of 12 point blah blah blah. So going back to our original graph here. Hang on. Going back to our original graph. So as x approaches 1 here, it's actually 12 point blah 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 blah. So this bit here is 12 point something. Okay. Yeah. Okay.